Okay, so now we're going to approach the question. Now that we've talked about absolute and conditional convergence, we're going to approach the question now. Given a series, does the series converge absolutely, conditionally, or does it diverge? Now, what you choose to do, you kind of have really two options. You can begin the problem by checking to see about the absolute convergence, right? Does the series of the absolute value, does that converge, right? Does the series of the absolute values, does that converge? In which case, the other series will also converge and will therefore it converges absolutely, okay? Or does this maybe not happen? It diverges. And then we just check the alternating series and see if it converges, okay? In which case we would say it's conditionally. Or does the alternating series, in this case, does it diverge? In which case we can say it's going to diverge, and so will the other one. We would say the whole thing just diverges. So which one you check first depends on kind of maybe what your instinct is as far as which one of these three conditions do you think it actually is. If you think that the overall thing's probably going to diverge, then check that first and see if you can get divergence, on the series there. If you can get divergence, all right, see if you can get that. But if you think the absolute value thing is going to converge, then check that first, because then you don't even have to bother checking the alternating series. So here, I look at my denominator of k cubed and I think, oh wow, this is a p series. So the sum of the absolute value of ak is the sum as k goes from 1 to infinity of 1 over k cubed. And I know that's a p series. And p series, as long as the power is bigger than 1, in this case 3 is bigger than 1, right, we know it converges. So therefore, when I drop the alternating sign, just look at the absolute value part, that series converges, and therefore the other one must as well. And so we say that it converges absolutely. It converges absolutely. Okay. It converges absolutely. It converges absolutely. So that time, since I suspected this being p-series, that it was going to converge, that's why I looked at it that way. Again, if you suspect that it's going to be something that's probably going to diverge, right? You're thinking of, ooh, the limit of the sequence, underlying sequence doesn't go to 0, so that it'll violate the alternating series test, then you may want to begin with that, not even bother with looking at the other way. Okay? So it's up to you how you start that, whether you look at the absolute series or if you look at the conditional series first, checking convergence. Again, typically, if I think it's going to work for the absolute value, dropping the alternating sign, if I think it's going to work, I'm going to do that one first. If I think the overall series with the alternating sign or whatever it has there isn't going to converge, then I'm probably going to start with that first, just to cut down on the amount of work that I would have to do.